everyone. I will present to you today our paper, which has been done in Chalmers University in the Department of Construction Management by myself and by Professor Koch. The lineout of the paper is as the following. I will not go a lot into the details of the lineout. We will start with the introduction, following traditional sequence until we reach our final. Okay, yeah, thank you.
There you go.
Yeah, perfect. So, construction projects are still suffering from problems with productivity and cost overruns, as well as scheduling problems. And then artificial intelligence is coming to be a superior solution to traditional methods in studying such complex systems. Therefore, we aimed at developing prediction models for cost variance, time variance, and the level of satisfaction for both the clients and the contractors. And through this process, we followed a number of activities of literature review and until we reached the prototype development of the machine learning prediction model. The framework of understanding which has been used in this study in the literature review and in the data collection as well as in the discussion was inspired by Yusufsson's work in 2013 and Koch and Lundholm in 2018. And basically the model is based on the assumption that general project conditions and project organization influence the performance of the project in terms of cost and time and absence of disturbances. The literature review, as I indicated a bit earlier, follows the same model of Yusufsson. But it's important here to note that we have taken the satisfaction of the contractor on board because the contractor role is especially important in facilitating collaboration in the project and to facilitate the work of the team around the construction project. It's important also to note previous efforts in predicting cost in the construction projects. So previous efforts used neural networks, regression analysis, and support vector machines in predicting or forecasting cost of construction, or even budget at completion or cost at forecasting estimate at completion. But we have seen that there is still need for deeper understanding of project performance and a need for studying the impact of project performance or project management on the project success, which previous efforts failed to fulfill. Therefore, we decided to study the assumptions about construction project success with the utilization of machine learning algorithms, and aim at finding tangible relationships between factors contributing to project performance and project success in order to have a comprehensive understanding for those. The material used in the data analysis or in the machine learning development was collected by telephone interviews and supported by survey questionnaires in the year of 2014, covering the product of construction projects in the Swedish industry, and covering aspects about the process, the organizational structure, costs, time, how work has been progressing, and the performance of different actors in the project organization, including the clients, the contractors, subcontractors, consultants, and suppliers. And then we have taken cost variance, time variance, and the level of satisfaction as the outputs which we will be trying to predict through the utilization of the machine learning. And it's important to note that we had a very high response rate covering 580 projects out of 1,000 sent questionnaires. And then these questionnaires were divided into two stages: the pre-construction phase and the construction phase, in order to make a model for each phase instead of making a model for the whole construction life cycle. However, there are limitations The data was collected by other people and not by the authors of this paper. Therefore, there were a lot of adaptations that we had to do in terms of cleaning the data, understanding the data, and making sense of what it means. So that was a very big challenge. The second challenge was the high variation in the output distributions. There were projects featuring very high cost overruns or very low cost underruns, let's say. The same goes for schedules and satisfaction. The final challenge was that the data collected is built on the perception of the respondent. So the respondent is actually trying to estimate and giving a scale for the level of performance, let's say, for other actors that they have been interacting with throughout the project. So it is a challenge to capture data that is based only on the perception of the people answering the questions. Our experiment started with using Weka software, which is a data mining software. And then in order to use the software and continue with the data analysis, a process of understanding the data and cleaning of the data has been done, which is a very consuming and time-consuming and very difficult task. And after that, the features in the data were selected by correlation-based feature selection in order to minimize the number of features that are used in the model prediction and to increase the accuracy of the prediction that we are going to make. Then the features that have been selected were used in a multiple linear regression analysis and resulted in 10 machine learning-based prediction models. For validation, we used cross-validation, 10-fold cross-validation, and root mean square error as an error rate to validate our results. However, the validation is only internal. So the validation has been done on the same data which has been used for the training. And we finally found that the best prediction model was to predict cost variance for the construction phase featuring 9.8%. However, time variance and satisfaction were very harder to predict, and by far the satisfaction was the hardest to be predicted among the 3 output measures that were taken in consideration. Our findings are as the following. We also structured our findings as the same structure of the model, featuring general project conditions and the project organization. And we have found that the general project conditions do not have a correlation with the satisfaction of the client or the contractor. On the other hand, cost variance and time variance are influenced by project attributes, such as project type or contract or even the gross area of the project. The most important features that were selected and used in the model are covering aspects regarding the client's role, especially in planning and facilitating collaboration, as well as providing good decision-making and encouraging innovation encouraging the main contractor to use innovative methods. The features selected were also covering investigations in the pre-design phase, covering the design phase, especially factors regarding the collaboration among the design team, the architect performance, and the good results of the design phase. The project program was also featured in a couple of features, as well as the production phase, especially factors related to the contractors, choosing of subcontractors, and managing the site, and facilitating collaboration with other project teams. The architect consultant was especially apparent among other consultants to be very important and to be having very much as the performance of the architect to be very related to the improvements in costs and time and even the satisfaction of the client. Our results even follow to cover the ventilation consultants and the piping consultants, featuring that ventilation consultants' innovative methods of working were especially important, as well as the piping consultants' quality of documents. So how did our prediction go? Basically, the machine learning was chosen because it was promising the improvements in predictability for important KPIs. But the fact is it's hard to actually understand how the model works in real life. So let's say that we predict the outcome of a project, cost variance or time variance, and we predict a very high cost variance. And then some changes happen in the trajectory of the project until the project reach a very good result and satisfactory performance. Then it's going to be really hard to understand if the prediction was actually working or not. One way to overcome this is to actually test the model on unseen data or have a new collection of data and do a new training and then compare the results between the different trainings. As we have seen earlier, predicting satisfaction was the hardest, but this is not a very surprising result, I guess, because satisfaction is a subjective measure and people have different perceptions of how they are satisfied with the project and the results or not. It's important also to note that the prediction is only approximate and not absolute, and there is still a space for improvements in the prediction models for cost and time variance. Finally, it's important also to note that the interpreting of the results is of special value, because let's say that a project featuring low cost variance, but this does not particularly mean that the project is performing well. Sometimes the cost variance might be a result of the result of how well the project was estimated in the first place. And there are some projects that have low cost variance by nature, let's say, for example, design and build contracts. So the machine learning results have to be very much looked at and looked at the underlying reasons why certain features have better correlation or higher correlation with the output than others. And therefore, the results should not be taken for granted. In our conclusion, we obtained a working model to predict project cost variance and time variance and satisfaction. And also in the conclusion, we have seen that the identification of the most correlating factors with the output is actually helping in the predictability of the output that the project performance is actually looking at. But the most important finding that we can share is that external factors are important for the project, but the most recurring factors behind project performance can be derived from human-related factors, especially collaboration and communication and common goals between parties. It has been seen in the feature selection that the collaboration has been apparent in the design phase, in the production phase, in the client performance measures, and in the contractor performance measures as well. So collaboration has always been apparent in the data, in the feature selection with the data that we had. There were also other factors featuring collaboration in indirect way. Let's say, for example, environmental requirements made by the client to the contractor. We have seen that when the client is requiring the contractor to have very high environmental performance, the project will be most likely to be meeting cost and time estimations. And maybe the reason for that is that when environmental aspects and environmental goals of the project are present, there is a very good common goal for the parties to work and collaborate together in order to achieve. Our recommendation for future research cover detailed lens of objective measures combined with machine learning, such as collaboration, client's decision-making, and satisfaction. So in our opinion, there's more research to be done in this area to have a better comprehensive understanding of such objective features regarding project performance. We also encourage on a focused research on single project processes, such as the design phase or the project program or even site management. Finally, we can say that our contribution to the body of knowledge is the illustration of machine learning as a method to study project performance successfully, and the comprehensive understanding of causes behind cost and schedule overrun using feature selection and machine learning, because using feature selection can provide a very detailed look at the causes of delays and let's say project success or failure, and especially with a very detailed lens. We can say also that the contractor satisfaction is our new addition to the literature. Usually the contractor satisfaction is overlooked and there's more importance being given to the client satisfaction, but on the other hand, the contractor also play a very important role in the project, especially in the, with the delivery of the final product. Thank you very much for listening. These are our profile contacts, and I am happy to have any questions.
Thank you. Thank you for a very interesting presentation.